At least it's pretty clear. Okay, today we're talking about the surface area and volume of spheres. And you'll notice that a lot of the terms that they use are similar to what's used with circles, okay? They're closely related. The first one is a radius, okay? That's a segment with endpoints that are at the center of the sphere and a point on the sphere. So, what would some of the radii be?
You got your AD.
AD would be one of them. I heard DC.
Yep.
And there's one more.
DB.
DB. Okay? A chord is a segment with endpoints that are on the sphere. So what would your chord be? FG. Is there another one?
No.
AB. Okay. AB is a special type of chord. What kind of chord is it? It is the diameter because it contains the center of the sphere. Okay. A tangent line. A tangent line is the same as it is when you're talking about a circle. It's a line that intersects a sphere in exactly one point. So what would my tangent line be? Okay, it'd be line GB. Could I call that GE?
Yeah.
Yeah, I could. When you name a line, you just have to pick 2 points that lie on the line. It doesn't matter which 2 points they are. You just pick 2 points. So I could call it line GE or BE or GB. What is E in regard to the line?
Point.
Say it is. It's the point of tangency. Okay? E is the point of tangency. Okay, now we have a new term, and this term is called the great circle. Okay? Now, the great circle is what is created if you take a sphere and you cut it exactly in half so that you get the center. Okay, if you have a plane that slices through the sphere so that it contains the center of the sphere and the radius of the sphere. This right here, this two-dimensional circle is called the great circle. So if you take the sphere, you slice it in half with the plane, okay, you get this two-dimensional circle called the great circle. You also get this three-dimensional figure called a hemisphere, okay? So the three-dimensional, the half of the sphere is the hemisphere, and then the circle that's created by the plane, like the cross-section, is called the great circle, okay? All right, and like I said, the radius of the great circle is the same as the radius of the spheres, okay? The radius of the great circle is the same as the radius of the sphere. All right, so let's look at our formula for surface area, okay? Our formula for surface area is 4 pi r squared. Very simple. If I told you that the radius of a sphere was 8, you'd plug it in and you would do 4 pi 8 squared and you'd get your answer, okay? Very simple. I'm not even going to take time to do one like that because it's so easy, okay? Now look at this next one. On this next one, it asks us to find the surface area of the sphere given the area of the great circle. Now, I'm kind of partial to this little sphere. I like puzzles, okay? And this is a glass sphere that's created by puzzle pieces. I thought it was kind of neat. I know it's kind of hard to see, but anyway. What I've done is I've given you the area of the great circle of this sphere, okay? What am I going to have to do? What do I need to do with this great circle? Okay, I could find the radius, absolutely. Is there anything else that you see you could do? You could plug in the area. Elaborate.
You can find how the area that times 4.
Ah. If the radius of the great circle is the same as the radius of the sphere, isn't this pi r squared?
Yes.
It is my pi r squared. And so you can come up here into your formula and you could replace the pi r squared with the area of the great circle. So just take the area of the great circle times 4. Okay? So you would do 4. It's the circle. It's a two-dimensional circle. It's the area of that circle that's created when you cut it in half.
So it's just like the circle.
It's just the circle. Yes. Okay. So it is 4 times 201.1, which is going to give me 804.4 inches squared. Now, if I had given you the circumference of the great circle, then I would have to have found the radius, okay? And you will have probably problems like that, okay? And in fact, we're going to do one here in just a second. All right, let's look at this next one. It wants us to find the surface area of the hemisphere, okay? We want to find the surface area of the hemisphere. Now, we learned that the surface area of a sphere was 4 pi r squared. So if we cut it in half and we end up with a hemisphere, what do you think the formula is going to be? Okay, I first thought that's what I thought too. Because if I take and I slice it in half, okay, it's 2 pi r squared. But remember, surface area is everything that's exposed to air. So if I do 2 pi r squared, I'm just getting this curved part, right? I'm going to have to add in the area of the great circle, okay? So when I cut it in half, I get the 2 pi r squared, but that doesn't include my great circle. I have to add that in, and so what would that be equal to? 3 pi r squared. Okay? So when you do the surface area of a hemisphere, it's 3 pi r squared. All right, so we would do 3 times pi times 6 squared. 36 times 3, I think that's 108. And if you plug that in, you get 339.3 inches squared. Questions on that?
This next part.
Yes.
It looks
Right. But I wanted to show you why it was like that. Because if I just said it's 3 pi r squared, why is it not 2 pi r squared? You know, so that way you understand. Okay. Now, the next thing we want to talk about is the volume of a sphere. Now, volume of a sphere is not hard. It's just kind of got a yuckier formula. But before we do that, I want you to find a particular button on your calculator. Because when you use volume, you have to cube the radius. Okay? So if I wanted to do, let's say, 2 cubed, or 2 to the third power, most of your calculators have this little caret button. And so you would type in your base, which is 2, and then you would do the caret button. It's like a little arrow going up, and then you would type what power you want it to go to. And so if you take 2 to the third power, you should get 8. So everybody find that button on your calculator. Some calculators have more like a y to the x, or an x to the y, or a y to the box, or the x to the box. Some of the calculators even have, find yours.
Yeah, right
Okay.
here.
Yeah, some of them even have a cube button. Okay. But the caret button allows you to take it to whatever power you want. Did everybody find it?
Yeah.
Okay. Okay. All right. So, our formula for volume is 4/3 pi r cubed. Shh. The formula for volume is 4/3 pi r cubed. Okay. So once we know the radius, we just plug it in and we get our answer. Okay. So 4/3 pi r cubed. My radius in this first example is 5. So I'm going to take 5 to the third power. So I'm just going to plug that in my calculator. I could do 4 divided by 3 times pi times 5 to the third power. And I should get 523.6 feet cubed. Everybody get that?
Yes.
Pretty easy.
Someone told me this was hard. I didn't
Why?
I don't
Asking
think
it's
like
hard.
this is
Every
hard.
day, that's what she says.
Okay, now we want to do the volume of a hemisphere. Okay, the volume of the hemisphere, what do you think it's going to be?
Same, like you.
You're just going to divide by 2, right? So instead of 4/3 pi r squared, it's going to be 2/3 pi r squared. Okay, so the volume of your hemisphere is 2/3 pi r, not r squared, it's r cubed. 2/3 pi r cubed. Yes? What? Yes. I don't know if I give you hemisphere, but it's half of a sphere. I'll give you the sphere one definitely.
Give us this.
You think so? You can take half of 4/3.
I don't know about that.
Yeah, but the other one is not.
Yeah. Yeah.
Ooh, you might have to think a little bit.
Yeah. I know that, right?
Yeah, I'm playing.
All right.
Why?
So we're going to plug this in. We're going to plug 16 in for R. And we're going to plug all that in. See what you get. 9,578.6 inches cubed.
Is it not better? It's not. If you put the 5 better. Like I have a fraction.
If you don't put anything there, it'll assume it's times.
Well, I got the same answer, but I'm putting it as a fraction. But so I guess you can put pi after it. It doesn't.
It shouldn't matter. So you did put yours in parentheses or not?
No, I didn't.
Yeah, that's okay. That's okay. And if you did put it in there, that would be okay too. Now, the thing you have to be careful with is if you were doing 2 divided by 3 pi. If you were dividing 2 by 3 pi, then you would have to put it in parentheses, but we're not.
It's the ion theory.
Yes, you are. All right. Last one. Okay. Find the surface area and volume of a baseball with a circumference of 9 inches. Okay? So this time, I give you the circumference of the sphere. And we know that circumference is 2 pi r. Okay? So what do we need from this? What do we need from the circumference? We need the radius. So I replace the circumference with 9. Okay? And I want to get r by itself, so I divide both sides by 2 pi. And so r is 9 over 2 pi. Now you could simplify this. Because 2 will go into 9 and get a terminating decimal, you could do that, and it makes the math just a little bit easier as far as plugging it in the calculator. Or you could work with 9 over 2 pi. If you work with 9 over 2 pi, you have to make sure that you always group that 2 pi together when you divide. Or you can go ahead and simplify it, but it would be 4.5 over pi. Okay? You could use either one of those. Okay? Okay. So, we want to do the surface area, which is 4 pi r squared. My radius is 4.5 over pi, and I have to square that. So what you might want to do in your calculator is do 4.5 divided by pi, square it, and then multiply it by 4 pi. And you should get 25.8 inches squared. That's surface area. I know, you got to always be thinking. You got to always be thinking.
Putting them into one lesson.
And volume. Now we have to look.
But it is good practice because when you do the test, it's going to be all mixed up. I'm not going to do all surface area and then all volume. It's going to be all mixed up. So you got to be thinking.
Volume on this, right?
Okay, so volume was what? 4/3 pi r cubed. So you're going to do the same thing. We're going to do 4/3 pi, and then we do the 4.5 over pi again, and we take it to the 3rd power. What'd you get? 12.3 inches cubed. All right, so we talked about surface area of the sphere, which was what?
4 pi.
4 pi r squared. Then we did the hemisphere, which was 3 pi r squared. Then we talked about the volume. The volume of the sphere is
4/3
4/3
pi r squared.
pi r cubed.
Oh my.
Oh my god.
And the hemisphere volume is
2/3.
2/3 pi r cubed. Okay. All right. Your assignments on the board.